Here we have a problem on evaluating limit. That is the limit extends to 0, sine cube x over sine x negative tan x. Okay, to evaluate the given limit, first we can use the coefficient identity for tan x. That is, tan x can be written as sine x over cosine x. Okay, let me write it over here. Limit extends to 0. I am writing the stuff in numerator as it is. In denominator, we have sine x. And for this tan x, we can write sine x over cosine x. So because this is a coefficient identity, so whenever we have tan x, so we can write sin x over cosine x because it is equal to tan x according to coefficient identity. Okay, so limit extends to 0, sine cube x over. Okay, in denominator, we have a subtraction between sin x and sin x over cosine x. Okay, now let's assume this is integer and we know that this is a fraction. So whenever I do subtraction between an integer and a fraction, what I need to do is I have to multiply the integer part by the denominator of the fraction. Once I'm done with this multiplication, I can take this denominator cosine x as a common denominator. Okay, so when I multiply this integer part sin x by this cosine x, I'm getting sin x times cosine x negative, and we have sin x over here. Okay, since I have multiplied this sin x by this denominator cosine x, now I can take the denominator cosine x as a common denominator. Okay, now let me continue with the next step. Limit extends to 0. Now I'm writing the sine cube x as it is times. Okay, now I change this division as multiplication. When I change the division over here as multiplication, I have to get reciprocal for the fraction over here. So when I get reciprocal for this one, I'm getting cosine x over sin x times cosine x negative sin x. Okay, so let me continue over here. 1 second. Limit extends to 0, sine cube x times cosine x over. Okay, here when I look at the stuff in denominator over here, in this expression, I find sin x as the greatest common divisor for these two terms. Since I find sin x as the greatest common divisor for these two terms, sin x can be factored out from this expression. So when I factor sin x out, so then I'm getting cosine x negative 1 inside the parenthesis. Okay, now we can verify the factoring what we have done is correct or wrong. So when I distribute this sin x to cosine x, I'm getting the first term sin x times cosine x. When I distribute this sin x to negative 1, I'm getting negative sin x. I'm getting the stuff over here. So the factoring what I've done is correct. Okay, so limit extends to 0. The sine cube x can be written as sine square x times sin x times cosine x over sin x times cosine x negative 1. Okay, this sin x and sin x can be cancelled, and I'm getting limit extends to 0. So we can multiply this sine square x and cosine x. Then I'm getting sine square x times cosine x in numerator, and in denominator I have cosine x negative 1. Okay, so now we can plug in the given limit for x over here. If I plug in the given limit 0 for x, what will happen? Let's check it. So then when I plug in x equals to 0 over here, it will become sine square 0. Already we know that the value of sine 0 is 0. So sine square 0 is also 0 because 0 square is still 0. And if I plug in x equals to 0 over here, it will become cosine 0. So cosine 0 is just 1. And here, so the value of cosine 0 is 1, negative 1. So in numerator, we get 0 times 1 is 0 and 1 negative 1 is 0. So when I plug in the given limit 0 for x into this function over here, I'm getting 0 over 0, which is called indeterminate form. Usually when we evaluate limits, when we get indeterminate form like 0 over 0, we'll be trying to use L'Hopital's rule. But before that, we have to check whether there is any possible simplification in this function. Okay, I think there is a possible simplification. That is, we have to multiply both numerator and denominator of the function over here by the conjugate of the denominator over here. What is the conjugate of the denominator over here? So in denominator, already we have cosine x negative 1. So if I want to get a conjugate of this one, so I just have to change the sign in the middle. Already we have negative. So if I change this one to positive, then I'll be getting cosine x positive 1. That is the conjugate. So now I have to multiply both numerator and denominator of the stuff over here by the conjugate of this one, that is cosine x positive 1. Here the cosine x positive 1. I multiply both numerator and denominator by cosine x positive 1. Okay, now let me continue. So limit extends to 0. Sine square x times cosine x times cosine x positive 1 over. In denominator, we have a product of the two binomials, cosine x negative 1 and cosine x positive 1. So let's consider the basic identity of algebra. That is like whenever we multiply two products, I mean two binomials in the form a positive b and a negative b, it equals to a square negative b square. So because here these two binomials are in the form of a negative b, we can consider this one as a negative b, this one as a positive b. So when I multiply a negative b and a positive b, it equals to a square negative b square. So at the place of a, we have cosine x. At the place of b, we have 1. Okay, so now we have to write a square negative b square, but instead of a, we have cosine x. So for a square, we have to write cosine square x, and for b square, we have to write 1 square. Okay, so limit extends to 0, sine square x times cosine x times cosine x positive 1 over. So cosine square x can be written as it is and negative. So the evaluation of this 1 square is just 1. Okay, now let me continue on the next page. This is the last step we had on the previous page. Okay, now I'm going to consider the Pythagorean identity, that is sine square x positive cosine square x equals to 1. Actually, this is Pythagorean identity we have in trigonometry. Okay, now so when we add sine square x and cosine square x, it equals to 1. Okay, now I'm going to solve for sine square x in this equation. So for that, I have to subtract cosine square x from both sides. Let me do it. Okay. So when I subtract cosine square x from both sides, so this positive cosine square x, negative cosine square x will cancel out. I'm getting sine square x equal to 1 negative cosine square x. Okay, so here for this 1 negative cosine square x, we can plug in sine square x. But in our problem, in denominator, we have cosine square x negative 1. So we have to get this stuff cosine square negative 1 as 1 negative cosine square x. How do we have to do that? Okay, let me do it in the next step. So limit extends to 0. So in numerator, we are going to write the stuff as it is. It is sine square x times cosine x times cosine x positive 1 over. Okay, now I have to get this stuff cosine square x negative 1 in this form of 1 negative cosine square x, so that we can plug in the sine square x for this 1 negative cosine square x. So how can we get this cosine square x negative 1 as 1 negative cosine square x? So when I compare this one and this one, so here cosine square x is positive, but here the cosine square x is negative. Here 1 is having negative sign, but here 1 is positive sign. So I have to change the signs of these two terms. So for that, what I need to do is I have to factor the negative sign. So whenever I factor negative sign from an expression, I have to change the signs of the terms in the expression. Since I factor negative sign out, this cosine square x will become negative cosine square x, and this negative 1 will become positive 1. Even if I distribute the negative sign to this one and this one, I am getting cosine square x negative 1. Okay, limit extends to 0, and we can take the negative sign in common over here. So then I'm getting negative sine square x times cosine x times cosine x positive 1 over. So this negative cosine square x positive 1 can be written as 1 negative cosine square x. So limit extends to 0, negative sine square x times cosine x times cosine x positive 1 over. And already we got the stuff that is equivalent to 1 negative cosine square x. It's over here. So we know that sine square x equals to 1 negative cosine square x. So we can plug in sine square x for this 1 negative cosine square x. So I'm writing sine square x over here. So the sine square x will cancel out. So then I'm getting a limit extends to 0, negative cosine x times cosine x positive 1. So that's all the simplification we can do. Now what we can do is we can plug in the limit 0 for x. Then I'm getting negative cosine 0 times cosine 0 positive 1. Already we know the value of cosine 0, that's 1. So we can plug in 1 for cosine 0. So again, we can plug in 1 for this cosine 0 positive 1. So negative 1 times 1 positive 1 is 2. Negative 1 times 2 is negative 2. So the evaluation of the given limit is negative 2.